The harvest season is here. Combines rolling across cornfields, gobbling up what looks to be a record or near record harvest. And our friends at John Deere already looking ahead to the spring of 2017, helping you with your production next year. Good evening. Welcome to this special edition of Rural America Live. I'm Mark Oppold. On location outside of Des Moines, Iowa, Bondurant, where John Deere held its Corn Production Seminar. And joining me this hour, co-hosting the hour, is Paulie Bradley from John Deere. Great to have you here. Thanks for having us here.
Great to be here, Mark, and welcome.
We have a lot of information to get into this hour. Talk about the four major areas we're going to cover this hour, if you would.
Yeah, we're looking at the corn production system, so growing corn and the field operations that are really critical. We're going to first look at the harvest step, Mark, and optimizing that. We're going to follow that up with applying nutrients with precision and with timeliness. Follow that with emergence and the seeding operation. And finally, to bring it all together, the importance of using data in the farming operation to make better decisions.
And today was all about giving your customers and dealers around the country an opportunity to get close in and learn about these things. We're going to start talking about residue management. Why are we covering that tonight?
It's really a critical component of raising corn, and it can be a friend, it can be a foe. So we really want to talk about when it's a friend, when it's a foe, and how to manage it beginning at harvest to set up for a successful next year.
All right, residue management up top. Let's take a look.
So today I'm going to talk to you a little bit about creating residue and how we affect creating that with the corn head. So I'm going to talk to you about 4 different stock roll options. So I'm going to talk to you about intermeshing stock rolls, which is where the knives on the stock rolls intermesh with each other. I'm going to talk to you about opposed knife rolls, where the knives on the rolls are opposed as they interact with the stock, and then the chopping function turned on and off on the corn head. So first off, I'd like you to look at this pass that we're standing in right here. And do you think this pass was harvested with a chopping corn head or a non-chopping corn head? Chopping, right? It's kind of low, you have a lot of fine residue. What do you notice about the residue mat? In between the rows, what do you notice with the residue? It's fairly even, right? There's a nice even mat across the board with this. So the other thing I want you to notice is the size of the residue. It's a little bit smaller, right? So with the chopping function turned on, can you tell a difference between these 4 rows, which was actually harvested with the intermeshing stock rolls, and those 4 rows that were harvested with opposed stock rolls? So if I pick up some pieces that I have down here in these buckets, these pieces were harvested with the intermeshing stock roll, and then these pieces were harvested with the opposed stock rolls. Sizing's about the same, right? So the story is here, if you're going to use the chopping function on your corn head the majority of the time, would it really matter what stock roll option you had on it? No. So keep in mind, these particular corn heads have the ability to have the chopping function turned on and off. So if you're the operation that has a lot of, say, bottom grounds or flat ground, and then you have rolling hills as well, you have the ability to turn that function on and off to get long and short pieces. So now we're standing in a pass that was harvested with the chopping function turned off. And keep in mind that the rows to my right, the 4 rows, were harvested with the intermeshing stock rolls. And then the 4 rows to my left were harvested with the opposed stock rolls. Do you notice any difference in the size of the residue? Yeah. So with the intermeshing, you have a little shorter piece. And then with the opposed stock rolls, you have a little longer piece. The reason being is, with the intermeshing stock roll, you're contacting that stock more often, and it's going to break that stock down. What else do you notice in between the rows as far as how the residue is distributed? What's different in these 8 rows as opposed to the 8 rows that had the chopping function turned on? You see a lot more soil in between the rows, right? So Harvester recently conducted a study last year that looked at the sizing of residue based on the stock roll option you might have. So as you look at this graph, you can tell that with intermeshing stock rolls, the majority of the time, the stock was in that 6 to 12 inch range. Now if you look at the opposed stock roll without the chopping function turned on, the majority of the time we were in that 12-inch and larger range. So as we look at the residue down here in the buckets, these are intermeshing without the chopping function turned on, and we're in about that 6 to the 12-inch range. If we look at the opposed stock roll residue with the chopping function not turned off, we have a lot longer pieces of residue, right? So again, that's without the chopping function turned on. So Iowa State recently did a study last year, and it was conducted over 3 years. So what they did is they took residue sizes that were from 3 inches to 6 inches to 1 foot to 3 foot. And they would incorporate that in the soil, and then they would also leave it on top like they were no-tilling. So over the course of those 3 years, what they found out is that decomposition was more a factor of moisture and temperature than residue size. So it may be a little confusing to try and think, well, I still believe that the smaller the piece, the quicker it would decompose, right? So decomposition is a factor of temperature and moisture, we said, and then microbes in the soil. So if microbes in the soil can get into that residue and start breaking it down, it really doesn't matter the size. So when that stock roll interacts with the stalk, it creates these little indentions. And those little indentions are big enough for those microbes to get in and start breaking it down. So those indentions on this particular piece with the opposed stock roll is about every inch to 1.5 inches. So in reality, those pieces are about 1 inch to 1.5 inches for those microbes to get in and start breaking that down. Same story with the intermeshing stock roll. As you look at it, you can see the interaction with the stalk and the roll is alternating. So those microbes can get in there and start working away at that piece of residue.
Today I'm in Iowa to talk to you about residue management. I'm going to be talking specifically about row cleaners and how I manage residue at the stage of the planting level. One thing I want to kind of drive home today is there was a study done a few years ago here in Iowa where they planted corn on corn 3 years in a row in order to study the effects of how residue affects corn seed. That study found out some interesting things, and I want to talk to you about that here today. One of the things that study showed us was there's a particular sweet spot when it comes to managing residue. And the number I want you to remember here today is the number 6. So I came up with a catchphrase so I could remember the number 6, and I came up with 6 is the sweet spot. 6 is the sweet spot. Let me explain why this number 6 is so important. I'm going to reference the chart that the study showed over here on my right. And if you follow the bottom of the chart, you'll see that this is the number of inches that we actually move residue in the field. On the upper axis, you can see this is the percent of yield I increased by moving that residue. So if you can take your eye and follow along the bottom of the chart, roughly to where 6 inches is, and follow it up to the black line, you'll notice that, ta-da, if I move residue 6 inches, I achieve roughly a 6% yield increase. Again, 6 is the sweet spot. Now I can see some of you are saying, Ken, if I move it 12, I get 12, right? Well, it doesn't quite work that way. If you looked at a 12-inch mark over here and followed it up to the reference line, you'd only see about a 7% gain. So roughly 1% is all you gained by moving a full 12 inches. So one more time, 6 is the sweet spot. Don't spend the extra horsepower and fuel to try to clear all of that residue away when 6 inches is enough. Now that we understand why 6 is the sweet spot, let's take a look at a couple tillage examples on how we can achieve good residue management. In the first 8 rows over here to my left, we harvested this with an 8-row John Deere chopping head. We followed that with a John Deere 2510S strip till machine. And I'd like you to just take a moment and glance down the length of the field across those 8 rows. Can you tell me, just gauging the level of blackness that you see in the soil, can you see some black and some residue in those row patterns there? If I was going to start planting this right now, would you recommend that I have a row cleaner on my planter? I see a lot of head nods. Yes, definitely want to have a row cleaner involved. Now that we looked at the previous 8 rows that were chopped and tilled with a 2510S strip till machine, let's take a look at the 8 rows right behind me. Again, this was done with a John Deere 8-row corn head, but this time the chopping was turned off. I ran the 2510S strip till machine through the exact same pattern. There's more black there, isn't there? So explain to me how the same tillage machine was used from those 8 rows to this 8 rows. Why do these rows look more black? Because they were not chopped. Let's take a look for a minute what that means. If I were to take a corn planter through these rows right now, would you suggest that I use row cleaners? Probably. Do I need to set them very aggressively? No, not really, because my strip till machine did a very good job. Let's compare the two different rows now. In this case, when I don't have the rows chopping, all of the residue is directly on top of the row. In a chop situation, the chopping mechanism chops the residue finely and scatters it all across the row. So as a result, my strip till machine has to work harder, my corn planter has to work harder to clear that residue to get that 6-inch sweet spot. Think about the horsepower and fuel I need to do so versus a non-chop setup. I have very little residue to move. For the next stop in the field, folks, I have 8 rows that were chopped with the John Deere 8-row head, but this time we came through with a John Deere 2730 ripper machine. And if you glance down the length of the rows here, take a look at what the blackness level looks like. What can you tell me about the residue in this section of the field? Less residue, right? It's finely chopped, it's finer incorporated into the soil. Now, take a look on my right-hand side. Likewise, this was done with the 2730 ripper, but this time we turned off the chopping head. What can you tell me about the residue in comparison on my right side versus my left? Much more residue on the surface, much longer pieces. So, are either of these ready to bring a corn planter through at this stage? Absolutely not. I'm going to have to do some secondary tillage come spring. Now that might depend on the soil type, the moisture, and a lot of other variables. Probably need to bring a field cultivator in over here to prepare the seed bed. After I field cultivate, would you maybe suggest row cleaners? Maybe, maybe not, depending on how that field cultivator performed. Over on this side with large pieces of residue, even after I field cultivate, would you suggest row cleaners? Definitely yes. Right? I'm going to have to do some action to clear those pieces away. I might even need to do another step like disking or use a mulch finisher to break up those pieces of residue.
Great information here for our producers tonight. Maybe 2 or 3 takeaways to leave with our viewers.
Yeah, when you think about residue and setting up next year, you really want to think about your tillage system and matching up your header on your combine and that configuration with the tillage system. It really does make a difference if you're a minimum till, no till, or strip till farmer, or if you're trying to bury it, the size of that residue.
You know, so what the producer is doing this year at harvest time can really set him up for a successful spring next year.
It absolutely can. It makes all the difference in the world because, as we know, when spring's here, it's time to get after it in the field, and you want to be ready and have that residue in shape to make that next pass as clean and easy as possible.
Very good. So, residue management, leading things off. We're going to move after a break here, come back and talk about nutrient application, why it's important, and to hear that presentation as well. Rural America Live continues. Bondurant, Iowa, the Corn Production Seminar, right after this. Welcome back to Rural America Live, on location outside of Bondurant near Des Moines, Iowa. And again, joining me, Paulie Bradley from John Deere. Paulie, a great lead off to our program tonight, talking about residue management. We're here now talking about nutrient application. Why is that important tonight?
Yeah, great question, Mark. We know that nutrients are the second highest input of corn producers today. And as you look at being a low-cost producer to deal with the economic times we're currently in, oftentimes managing nutrients a lot closer with more precision and more timeliness is a key to being a low-cost producer.
Let's take a look at that presentation.
My name is John Hogan. Today I'm going to be talking about 4 main topics as it relates to nitrogen placement. We're going to be talking about ways to potentially gain in productivity as well as profitability as it relates to nitrogen placement. So the first thing we're going to talk about today is the spring diagonal NH3. What I've got here on my board, we can see I've got a strip trial. This was my spring NH3 pass. What you can see, we see some diagonals in that, all right? Some perpendicular to the row, places where we can see some burning and some toxicity in that plant. So anytime we have anhydrous intersecting the crop, we have the potential to see some of that burning, some of that plant stunning. Now back here is we're going to actually take a look at that root burn, and we can see with my field example here, this little plant right here yielded 116. You can tell the spindle, the stalk size is definitely smaller. As we look down through, we can definitely see the gap in that pattern perpendicular to the row. What we can also see is as the knife got further away from that diagonal, it actually comes up the yield's going to come up where it was pretty much optimal to where the knife was, and it's going to start to go back down. So we're going to see that inconsistent path all throughout the field where we did that diagonal nitrogen pass. So with that being said, we're going to talk about parallel on-row application and how we can get more consistent plant size and that nitrogen placed precisely where we want it from the crop. We just showed the spring diagonal and how that variable in-row yield is an effect of that. So we're going to talk about the criticality of the placement of in and the specific distance to the row. Do you think it makes a big difference whether it's 15 inches, 10 inches, 4 inches? Well, the studies we looked at said roughly a 10% increase in yield by placing it within 6 inches of the row versus other treatments, so other distances from the row. That being critical, you know, as we're planting that, RTK is definitely a good idea, right? Absolutely, we're getting sub-inch accuracy. We're getting sub-inch accuracy at the tractor though. Do you think we're getting sub-inch accuracy where we're actually dropping the product? Not a lot of the time, right? So if the ground's not flat, we've got a 60-foot toolbar, it's walking back and forth a little bit of degree angle on that can really throw us off as far as where we're at in the relationship to where we really wanted to place that product. So one of the things we want to talk about today is active implement guidance. Active implement guidance is a product that helps us steer the implement on the row and puts that product precisely where we want it. The two pictures I have on this board, you can see there's a strip till rig as well as a planter that have the receivers mounted on them. So if we have our receiver mounted on the implement, we also have a mechanical component that's going to help us actually steer that implement right to where it needs to be to help us place that product right where we want it. Couple different ways we do that. Orthman has in-ground engaging coulters that actually steer the machine on row. There's also hydraulic hitches. LaForge is an example of that actually moves it back and forth. My picture on this board down here, you can see this is actually a LaForge hitch that will move it back and forth and keep it on that row. This was a test machine. The studies that we did shows on a less than 1 degree of roll angle. Put it in perspective, it's less than about 2% slope, so it's pretty close to tabletop flat. The more hills we have, this is actually going to provide a better benefit for you from that. So we look at the conventional, so that's without active implement guidance in the test we ran. That gray block on the left, or on your right, says 48%, and that is greater than 2 inches. So 48% of the time, we were greater than 2 inches off just running it standard with RTK on the tractor only. When we added in active implement guidance and turned it on, we went up to, and that green bar represents less than an inch, we went up to 70% of the time we were within less than an inch accuracy. So, you know, as we talk about a lot of the solutions that we have, it's not always about buying a new machine to try to do different things. Maybe it's adding something else to that machine that we've already purchased to help that efficiency. So active implement guidance is a great tool that can help us do that.
So in today's session, we're really going to be discussing nitrogen timing. So the two main areas are fall versus spring anhydrous application, as well as a discussion around late season nitrogen application. So if we start off with that fall versus spring nitrogen application, let's kind of talk about that a little bit. So if we think in a typical application, when we apply anhydrous, probably in that fall time frame, okay? We get done with harvest and we have a little bit of time there to go ahead and put on that anhydrous. Now what we're going to really discuss today is where we see a pretty good yield gain by moving that application to the spring time frame. So if we look at this graphic here, we do see, as we compare the percent increase of yield over the precipitation, that even underneath an average precipitation year, we have a 7% average yield gain by moving it from fall to spring. Okay, so that'd be with anhydrous. So that's a pretty big yield gain even underneath an average precipitation year. And a lot of that goes back to Mother Nature. So if we have those high rainfall events, which we are accustomed to nowadays, then we will see a yield gain. Now the next one is dry, so a dry year. And if we notice this data here, it kind of shows NS and it's kind of in the negative numbers. So that would tell us there is no significant difference in a dry year. And that goes back, and that makes pretty much sense. We're not having those high rainfall events. And our biggest yield gain is in those wet years. Get those very high precipitation events, kind of those duck drowners we like to call them, we're going to see upwards of a 13% average yield gain in those wet years. So like I mentioned earlier, our plants are needing more nitrogen, that corn plant's needing more nitrogen, especially later on in the season. And if we go back to Mother Nature, if for some reason we're losing this nitrogen, due to these rainfall events, we're going to see a yield drag. So this graphic does a good job kind of just explaining how a corn plant takes up nitrogen throughout its growing cycle. Now the area we're really going to focus is later on in that season. Okay, later on in that season, we see when that's actually filling that grain. So we're now shifting away from the vegetative stages. We're no longer worrying about the leaves for photosynthesis. We're actually moving into where we're filling that grain. Okay, we're getting that kernel created and getting that kernel depth. And we see we still need 33% of the total nitrogen, which is approximately 70 pounds per acre in that reproductive stage where we fill that grain. So how can we apply nitrogen later on in the season? So hopefully all of you have heard about our new joint venture with Hagie. We can now have a high clearance sprayer, and we can get in there and apply that nitrogen either with this nitrogen toolbar, or what we'll talk about here in a little bit, another product that is very great for applying late season nitrogen. So let's go ahead and look at some data that helps back up this yield story, or this yield bump from late season nitrogen. So if we take a look at this chart here, again it's showing the percent increase of yield versus various methods of applying. So the first one is comparing V6 to V10 underneath high precipitation. Now we see a little bit of a yield bump there, around 3%. And if we go back to our graphic over there of the uptake, you think about the emergence to V6. Again, we're not taking up very much nitrogen at that point, so that's why we don't see as much of a yield bump. Now where we see the biggest impact is post V10. Okay, so after V10 we come in and apply that late season nitrogen. And again, underneath the high precipitation event, going back to Mother Nature, we're probably going to see the biggest yield bump. So around a 10% average increase by applying a form of nitrogen later on in that season post V10. And moving on to our last graphic, so if we get into that very late season, maybe around that VT stage, we can also look at a new product we have an agreement with, the Y drops from Yield 360. So this is a great product to apply liquid form of nitrogen near that plant base. So as you can see with these graphics here, there's kind of these little tubes that follow along the stalk of the corn plant, and we can apply that liquid form of that nitrogen. So as we go back home today, kind of think about some of the solutions we talked about, the Y drops, the Hagie high clearance sprayer, John Deere nitrogen toolbars, especially that 2510H, as well as our 4 series sprayers as great solutions to either move that application from fall to spring or to help with some late season nitrogen application. So kind of get those thinking and talk with your agronomist as well.
And today we're going to spend some time talking about potassium and phosphorus in the dry nutrient application, particularly around our different types of application, banding versus broadcast. So we set up 3 different trials this spring. The first one was a 15-inch offset band. So we went through, put our band of nutrients down in the ground, came back and planted our row of corn 15 inches away from it. The next time we did the same thing just 3 inches away. So band of nutrients, planting that row of corn 3 inches away. And then the last one we went through, we did a broadcast application, incorporated it, and then planted into that. And the results were really pretty striking fairly early on. The picture that you see right here is taking a look right down between the 15-inch offset versus the 3-inch offset. And these little guys over here, they're that 15-inch offset. The ones that you see there to the side that are a lot taller, that are fuller, they're from that 3-inch offset. We were thinking about that this summer and said, well, okay, was that just the spring? Is it really tied to that nutrient placement? What if we went out into the field and planted it now? Would we see the same thing? So we came out into the field here in Iowa and we planted that exact same replication. We took a band, put it down, and then planted the seeds 15 inches off from it. We did the same thing with a 3-inch offset, and then again we did the broadcast. And that's what you see here in this plot right behind me. So we look between these and we say, okay, well, 3 inches is better than 15 inches. But if we look down there at the broadcast, we say, okay, well, it doesn't look quite as good as the 3 inches, but I'm going to venture that it looks better than what our 15-inch does. So with that in mind, kind of where is that line at? How close do we need to be? And with that, what are some of the requirements that we're going to have? If we do need to get that 3-inch offset, we're going to need to incorporate some precision, right? We're definitely going to need to have some guidance involved. We're going to look at a very accurate signal strength, so either RTK, or if we're utilizing that new Starfire 6000, using some SF3 so we can get that in-season repeatability, right? Using your guidance line to put down your band of nutrients, coming back in, using that same guidance line, shifting over to do your planting row. Now shifting over, we said we got to do that. Well, how far do we got to go? Let's look into that. So as far as that placement and how close we need to be to that crop row, so what we see in this chart here is the yield that we achieved, and along the bottom is the offset that we were from that row. And what we see is when we had a 0-inch offset, we were right underneath that row, we got the greatest yield. With that in mind though, please don't go home and take a seed and put it right on top of your nutrients, because if you do that, you're going to be really unhappy with me and you're going to come back and yell at me. I don't want you to do that. If we do that, we're going to get a lot of toxicity, we're going to get a lot of burn, and nobody's going to be happy at that point. So if you do want to do that 0-inch offset, you need to make sure you're getting some depth, that nutrient down underneath that seed quite a little bit of ways. With that in mind, we're going to need to be looking at doing some strip till to get it down. If, however, you didn't really want to get into strip till, you wanted something to go a little bit faster, have a little bit more productivity, maybe lower disturbance, you could look at doing, say, a 3-inch offset and utilizing that 2510H with a dry nutrient attachment. That's going to allow you to get through that field real fast and get that nice placement a little bit away from the seed, say about 3 inches, and down 3.5 to 4 inches, right in that root zone, right where it's going to be able to get to that nutrient there. Let's say we wanted to move outside of that 3 inches. Once we get down to about 6 inches, we really start seeing that yield falling off, right? So that's kind of something we want to keep in mind. 6 inches sees that yield fall. But we also need to take into consideration, well, how far is our broadcast going to be in there? And what we actually saw was the exact same correlation as about 6 inches. Our yield results for 6-inch banding and a broadcast were pretty much the same. So with that in mind, if we can band within 6 inches of that crop row, we're going to see a yield benefit. If we can't consistently, you're going to be better off to go ahead and get that broadcasted, get it in the plant root zone that it's going to be available, or else you're going to start sacrificing some yield. So with that, how much yield gain are we looking at? We compiled research results from over 25 different university studies, and we came to the conclusion that if you band phosphorus within 6 inches of that crop row, you could see anywhere from a 3 to 9% yield increase, averaging out here at 6. Now with that in mind, we only saw that with phosphorus. We didn't see that with potassium. Potassium had no statistical significant difference if it was banded versus if it was broadcasted.
Paulie, great information as always. Maybe 2 or 3 takeaways you want to leave with our viewers.
Yeah, first, when you look at the 4 R's of nutrient stewardship, really timeliness and placement are a couple of opportunities. And placing nitrogen relative to the corn row is really important, being consistent and giving every plant equal opportunity to make yield, and also timing that nitrogen with the need and the uptake of that crop is really critical.
I thought when they were talking about active implement guidance, you get down to 1-inch accuracy 70% of the time. That has to be huge for the producer.
Yeah, and that's on sloping hills. So it's really, you think that if you have very gentle slopes, you probably don't need that. We're seeing that even in gentle slopes, 2% in that area, active implement guidance really keeps you on task. And when you're talking about ensuring differentiation of 2 inches with a crop row, that's really important.
You wouldn't think 1 inch make much difference, but it certainly does.
It certainly does.
We found that out here. Very good. We're going to move on to uniform emergence. I thought that was interesting as well. I got a lot of notes on that. We'll come back and talk about uniform emergence. We continue from Bondurant, Iowa. Welcome back to Rural America Live. On location, Bondurant, Iowa, part of John Deere's Corn Production Seminar. Again, joined by Paulie Bradley. Paulie, we left talking about nutrient application. We want to talk about uniform emergence, and we're near a test plot here that, well, it's a great example, but I don't think this corn is going to make 200 bushel an acre.
Yeah, it probably won't, Mark, but it's a great show plot to demonstrate the importance of uniform emergence and what factors can really impact it.
And why is that important that we're covering that topic tonight?
Yeah, it's a really hectic time of the year in the spring, Mark, and there are factors that producers can control and those that they cannot. So we're really combining some of the technology at planting time with some common sense approaches to ensure that you're focusing on the factors that bring home the most yield possible.
Uniform emergence, one of those factors. Let's take a look.
Now, when we look at your decision-making process, when it comes to factors that actually influence that potential yield at the end, but we're going to focus today on the planter side. And when we look at the planter side, there's 4 key areas: that uniform emergence, that optimal planting window. We're talking about our correct populations, And the key one we're going to focus on today is the uniform emergence. Because if you notice, we can actually have that 5 to 8% impact on making sure we manage that. We got a shot here of a picture of a field. Does that look good? If I had that out in the field, does that look good for you? I got some head shaking, no. Give me one good thing on that one, though. On this slide, what's one good thing that jumps out at you? Spacing. It has really, really good spacing. But what's the bad thing you see? What's jumping out at you is like, ooh, I don't like that. Plant height. And so when you think of uniform emergence, we want those plants to emerge with uniform height, uniform size, so that way they're not competing against each other. So when we look at residue as one of the factors that we have to manage, what do you think of this picture? Is that good? Bad? It's a trick question. Why? It's an agronomic question. It depends. Exactly. It depends. Because if I can get that residue off of the row 6 inches away from where that plant and that seed is, then I'm okay. But if I keep it there, it may have some negative effects. So let's look at this next picture here. See that row to your right. Compare it to some of the rows on the left. Is there a difference in height? Difference in color too, right? So look at that residue. That residue didn't get cleaned off of that one row. See that? That yellow looking row? I'm going to refer to it as the yellow looking row, the easiest to determine. Notice that yellow color. After the plant is started to grow, you notice there's difference in colors. That's that yellow row and the green rows. Do you think that residue is having an effect there? Yeah, that residue can actually tie up nutrients availability for that young plant. And you can actually see the color difference there compared to the other rows just 2 away on that other side. So residue management of getting it off the row, clearing that row can help with the temperature. It can help with the management of getting the uniformity, the depth, and that is significant. So what do we have as tools that help us to manage that? Is we have row cleaners, right? But what if you, from the cab, could pneumatically adjust it? Hit a button, pneumatic system, adjust that. Think you're more likely to adjust for changing of field conditions? We actually have that as an option. So when we think of the options, you got your standard row cleaners, but we now have the tool of pneumatic row cleaners that can help with this process. All right, let's look at depth. As we look at the planting depth, we have a 2-inch and 3-inch test here. And if you notice on the left side, you have the 2-inch depth. It's up, growing good. And on the right side of that growing picture, that's barely starting to get through the ground. Well, what's one of the key things that's affecting it beyond the fact that, yep, it's got to go an extra inch? Is temperature. And when we talk about temperature, you can actually have a 4-degree difference in that 1 inch of depth. So what do we have that helps keep us at that right depth? Our downforce management, right? And when we look at our downforce management across that field, we've got a couple different options. If you think about if I got a uniform field, uniform type conditions, a pneumatic system may work really well to maintain that proper depth. But if I have a very diverse field where the textures are different, I go from hard clays to soft sands within that same field, well, I may want to have a quicker change, or I may look at hydraulic capabilities on my downforce system to have that quicker change. And so those are options that you can look at to try to maximize your ability to keep proper depth with downforce. All right. Seed to soil contact. Vital, right? Because why is seed to soil contact so important? We got to get moisture to the seed, the correct moisture to the seed. So if I have not enough closing wheel force, I may have air pockets around that seed. And if I have air pockets around that seed, it may not get the moisture it needs, right? And what if I have too much? Then that seed's got the compaction issue to deal with and try to fight through, and then the roots have the issues of the compaction. So we want to have that just right. So what's our management of the good seed to soil contact? Our closing system. And so when we look at that closing wheel system, it's kind of like the row cleaners. Think about my closing wheels. I got my T-handle. I'm manually adjusting the pressure, the force that I have on that closing wheel, okay, to get that good seed to soil contact. Now, what happens if you got changes across the field? And with those changes across the field, how often do you stop and say, all right, I'm going to change every T-handle on that 24 rows? Anybody do that? Not very often, do you? All right. So what if you had a pneumatic system where from the cab I could just go ahead and punch a button and actually adjust it? You're probably more likely to make the adjustments. But how do you know your adjustment's right? You get out of the cab and you dig. You still can't get away from the situation. You must look at what you're doing visually by getting out of the cab, digging. Do I have really good seed to soil contact? Is my depth correct? Is my spacing correct? And verify that. So then as you're looking at your monitors, is it matching what's happening behind the planter? So what's the technology that we have that can help us plant with confidence to verify what we're doing? Is SeedStar Mobile. As an additional tool where we can look at row by row on our monitor and we can see where are there some possible issues that we can get to that individual row and make adjustments while we're planting. So when we look at this tool, we can look at CLV, and we look at spacing, we can look at our population, and with that row by row effect, as you see on this picture here, you see, let's say the little red mark showing up, and you're like, oh, let me get to that individual row and make adjustments. There's a big advantage that you have with SeedStar Mobile from an efficiency standpoint of getting that planter optimized while you're planting, because when you're done planting, it's a little too late. And then also we can utilize that data as part of our data management system.
So one of the things we're going to look at today is the effect of temperature on uniform emergence in a field. A Purdue University study took a look at the mean days to get 50% emergence. 50% emergence within that 24 to 72 hour time frame is what we would call uniform emergence. So we take a look at the mean temperature during emergence and compare that to the number of days that it takes to get to 50% emergence. And we can see temperature has a large effect on that. And as producers, you understand that already, right? That temperature is vitally important to having uniform emergence and getting that germination to the seed. But one of the interesting things when we look at this data is even going from 55 to 60 degrees, that time to 50% emergence really decreases. So being able to wait for that soil to warm up just a little bit more can pay large dividends on getting uniform emergence. And something that also plays into temperature is that optimal planting window, right? That's something, again, that a lot of land-grant universities look at and study, is finding that optimal planting window for their specific regions. We know that once we get about 2 weeks outside of that window, yield starts to drop off. So every spring we try to hunt that down. We look at temperatures, we measure soil temperature as well to see when we get going. One of the things that we can do though, with technology like the ExactEmerge planter, is have the power to wait for that optimal window. Whether it's temperature, and we can wait a few more days for that soil to reach the optimal window to get out and get the work done, or maybe it's a rain event that prevents us from getting out into the field to go. If we can wait 1 day or 2 days longer for that field to dry down and get the conditions to be optimal, we can really do a better job at planting. We can get into that temperature window that the Purdue University study mentions and get the best emergence possible for our crop. We're going to take a look at how compaction can impact uniform emergence and ultimately yield. And how we're going to combat that is to take a look at how we can optimize your tractor setup primarily through tire pressure and ballasting to reduce compaction and to increase yield on those pinch rows. So when we take a look at ballasting in general, take a step back, what we're really trying to do is add weight to the machine to drive traction, right? We want to get that power to the ground. But once we've hit a spot where we have the appropriate amount of ballast, all the weight that's on that tractor additionally added is just waste. We're wasting fuel, we're increasing our tire pressure, and by increasing our tire pressure, we're driving additional compaction and we're losing traction, or that power to the ground. So when we take a look at a study that was done in Illinois, just looking at differences in tire pressure, when we look at yield inside of pinch rows on a tractor that was not optimized, we're looking at a 23 bushel per acre difference on those pinch rows versus non-pinch rows. Now, when that tire pressure is set optimally down to 8 PSI, the yield in those pinch rows is only 9 bushels per acre, about 9 bushels per acre different from pinch rows versus non-pinch rows. So you might be asking yourself, okay, 1-2 rows per pass that are impacted by pinch rows. How big a deal is that really? Well, if you have a 24 row planter, 1 out of every 12 rows in your field is going to be a pinch row. So if we have a 14 bushel per acre difference on optimized versus not optimized over on 1/12 of our rows, take that over the course of the field and you're over a bushel per acre impact on your entire operation. Start calculating that out dollars wise. Now you're at $3 to $4 per acre that you can add to your bottom line just by making sure that your equipment is optimized for the job that it's doing. You can take this a step further even as we go into harvest this fall. Anyone know off the top of their head the grain tank capacity on an S680 combine? 400 bushels. We got a trivia expert on staff. So 400 bushels, right? And how much does a bushel of corn weigh?
56 pounds.
56 pounds in a bushel. So doing some math there, 400 bushels at 56 pounds per bushel gives us 22,400 pounds in that tank when we're full. We have a 7R tractor with us right now. The base weight on that tractor is between 22 to 23,000 pounds. So next fall, when you're this upcoming fall, when you're combining and that grain tank's full, you're carrying the equivalent of a 7R tractor in that combine. So if we can reduce the amount of grain that we're carrying across the field in that combine, we can reduce that impact on compaction as well and further drive that yield when we get to the spring.
Great information as always here on uniform emergence. Maybe 2 or 3 takeaways you want to leave with viewers.
Yeah, I think one takeaway is, again, technology is available today to help producers really fine-tune their planter operation, even down to a row-by-row situation to optimize that uniform emergence, Mark.
You know, you talk about a lot of times in the football game, it's a game of inches. We certainly heard that getting off the tractor, getting down on your hands and knees, digging in the dirt and seeing if you're within that inch or 2 that you need to be.
It is. It's important to initially calibrate that. And once you do that and you calibrate your equipment and your technology, now it's available to give you that picture from within the cab to show you what's going on at all times and help you plant with confidence.
Very good. We have talked about this uniform emergence. We're going to move on to our last topic here, and that is data enhanced decision making, and learn about that. Be right back after this.
The reason you're here is to be best in class. Best in class in a down ag economic environment. It challenges all of us. It also provides an opportunity for us to improve, to learn, and to lead. Now, some of you were at the LEAD event in December back in Moline, and Dr. Bulgy, a professor of ag economics from Purdue, I thought summed it up very well and said, how do you respond to the ag economic environment we're entering? And he said it's to be best in class. To be best in class in these 8 areas. So we'll run down through them here real quick. Intense cost control, margin management, execution, your buying right, the logistics management, managing risk, debt and capital management, and automation and simplification. Now you see 5 of those up there that are bolded. The reason is they're bolded is we're going to touch on all 5 of those topics here today. And you're going to see some good examples of practical uses of data to help you with those 5 things. So what do we mean by those? So around intense control and margin management, that first starts with efficiency and productivity, and that is critical. Now think of productivity as a quantitative measure for your day. So if you said you had a productive day, you would say, I covered a lot of acres, or I got a lot of fields done today. That was a productive day. An efficient day would say, how did I use the time within that day? So an efficient day, think about, did it eliminate waste? Like, was I doing things that were, wheels turning, getting actual work done, or was there waste in there? The quality of that work that was being done. When you look at the corn behind me, that's every single plant where they put in uniformly, so that impacts the outcome. And so think of that efficiency and productivity. The other side of intense cost control and margin management is know your cost components per unit sold. So what does it cost me per bushel? And the example I have up there is best in class is taking that down to the field level and subfield level to know where throughout the field am I making or losing money, and would that drive me to manage that differently? I want to pause for a moment on that map, because you may be looking at that and wondering, where do I see that in the John Deere system? Well, that's because that's one of our integrated partners called AgDNA, who provides tools to the John Deere dealers to you to allow you to be able to manage these kind of things. And they specialize in things that us at John Deere, where we can focus on the equipment and getting the information to you. With the JD Link Connect, that information comes straight from the machine to the operations center, and the integration with the systems that you choose to connect with the operations center, the information is just there. That integration, and you'll see on the boards up high, those are the integrated partners that are integrated into the operations center. Each of those specializes in a certain area. And some of that integration is with people. So think agronomists or crop consultants you work with. The second area, being best in class, I want to touch on is around execution. So think of the first thing as standard operating procedures, or SOPs. These can be very advanced. They can be very basic. Your father-son conversation around how are we going to attack this work today. It's what's our plan of attack, or your game plan. That can be just a verbal conversation just to make sure you're on the same page. And some of you have large operations with many employees and need to write that out in a way that everybody understands this is our procedure. The second area of execution is around timely operations. You're all from different areas throughout the Midwest, and you all know the optimal planting window for each of your areas. And that's why at John Deere we provide tools like SeedStar Mobile, where if you're pushing that window and you need to maybe push speed a little bit and say, well, if I push speed, will I sacrifice the quality for that seed uniformity? It's having that information right there. If you see a trend pop up when you're pushing that timing, and you can spot that trend. If you see red come up on that map on the screen, you know you've got an issue with that row. Now, best in class don't just look for the red. They look for the yellow in those maps. They look for the light green, and they try to drive for perfection in that uniformity. Then lastly, around execution is details, and details really matter. It starts with, think of planting, of getting out of the cab, checking the seed, checking the depth. Depth can have a big impact on yield, and so checking the details at the time when you can have an impact on it before it's too late really matters. And even myself personally, I may say, Jeremy, what's that picture up there? That's actually from my office, and while I work with Digital Ag Products, I'm very much grounded into the corn plant, and every step along the way, I get eyeball level with that plant to really understand what impacts it and what influences it, and what can we do with technology to provide a better outcome. The other areas around logistic management. So think of the machinery, the inputs, the products, and all that flow scheduling. That's your tenders, those are your grain carts, that's the work that's happening in the field and how all that flows together. That's why in the John Deere Operations Center, why we enable tools to allow you to put that plan together, to put your work orders together for each individual field, push that to the machine, and the operator can just select the work order, get their work going, and not have to worry about you know, the logistical side of that. You can manage that. Another area around logistics and way to optimize that is some of you have a couple different planters. You may have 2 planters, and you know, in the past, it's probably been common practice that one planter goes over here and does this field, another one in another field. And that's because you use things like section control so you don't overlap. This one has this guidance line, so it's using that guidance. The other one uses different ones. That's why this past year we provided JD Link Connect machine sharing. It's really syncing 2 machines for their coverage and for their guidance lines so they can work as a team. And what that means for logistics is it allows you to put that seed tender and fertilizer tender right there where the team of machines are working, and you can be more efficient. Then I mentioned that timing, you know, hitting the optimal planting window. Sometimes you got to push speed. Sometimes you got to push hours. That's why at John Deere, and you're going to be seeing tools like this come from us very shortly that allow you, as if you're the manager of your operation or the owner, you can see with confidence that things are going as they should in the field with your equipment. And lastly, I want to touch on simplification and automation. And that's where you want to get to that picture on the right where it's simplified, it's automated. Remember I mentioned the work orders and the logistics flow, how that wirelessly goes right to the machine where you can select that work and focus on doing a great job in the field. The question is, do you have that complete data set? A sure-footed decision really tells you have data backing up this decision. I can know with pretty good certainty that I'll have a better outcome. And so leverage those examples, and lastly, consider what needs to change on your farm in order to adopt these examples and some of the technology that can help you farm better.
Again, great information, data. That's ever-changing, but a lot of great information today. A couple of takeaways you want to leave with viewers.
Yeah, Mark, as the old adage goes, you can't manage what you don't measure. And today's technology enables you to measure so much on your farm, whether it's logistics, your fleet, or your inputs.
Mm-hmm. And it's been a fast hour here. Wrap things up for us, kind of take us full circle and things to leave and for our viewers to consider.
Yeah, really one of the themes that we have here for customers this week is focusing on the agronomics and the agronomics that enable economics, mm-hmm. which make you not only a low-cost producer from a cost perspective, but we know that also means that you can be a higher yield producer. So that starts with harvest,
right,
with managing your residue and fitting that residue management plan with your tillage system. Follow that right up with nutrient placement that complements your farming system, because there's a lot of opportunity to gain yield and perhaps cut a little cost by being more precise with placement and timing. That seeding operation is in a really hectic time of the year, so what are the really critical things to focus in on? We know that uniform emergence is really important, along with optimizing your tractor and your equipment, and then tying it all together with a lot of data that you already likely have, but leads to better decisions from insights from that data.
Very good. And where can our viewers learn more?
They can learn more at johndeere.com/agronomic. And if they have questions about products or product availability or how to optimize their products, they can also see their John Deere dealer.
Thanks for having us out here. Been a great day.
Thanks for being here, Mark. It has been a good one. It's been great to have you.
We really enjoyed it. Thank you very much. Paulie Bradley here again, the Corn Production Seminar on location here in Bondurant, Iowa. Good night from rural America's most important network.